light and matter. This is the topic of discussion in today's lecture. Here light means, it is photon particles, and matter is here electrons. So the topic of discussion is interaction between photon particles and electrons. Okay, this is the matter of discussion. There are three types of scattering: Thomson scattering, Compton scattering, and Rayleigh scattering. And all these scatterings are interaction between photons and electrons. First is Thomson scattering. Here the electrons which are taking part in the collision process or scattering process, these electrons are free electrons. They are not attached to any molecules or any atoms. They are completely free to move. Okay, and here the incident photon particles are light rays. Okay, and also low frequency X-rays can also be used to get the effect of Thomson scattering. Okay, so low frequency X-rays can be used also along with light rays. So here what happens, the wavelength or the frequency of the light rays which incident upon the electrons and the energy of the scattered photons are same. Okay, whatever be the angle, means here energies remain the same. That means here the collision between photon and electrons are elastic in nature. You know that in case of elastic collision there is no loss of energy. So this is for Thomson scattering. You would find application of Thomson scattering in case of to study the behavior of light in case of stellar atmosphere or for the corona of sun. There you would find the application of Thomson scattering. Okay, the behavior of light in case of ionization of gases, this Thomson scattering is used. Next is Compton scattering. Compton scattering, this is inelastic in nature. This is not elastic. Collision is not elastic. That means there is a change in the energy of the scattered photons. Okay, here the photon particles which incident on the electrons, they are X-rays, either they are X-rays or gamma rays, means frequencies are high. Frequency of the incident photon particles are high and they are causing scattering after collision with the electrons. Depending upon the scattering angle, the energies of the scattered photons are different. But here the photon particles cannot impart its full energy to the electrons due to the conservation of momentum and energy principle. Okay, because after the collision, both the momentum and energy are shared between the electrons and photons. Okay, that's why the photon particles are not able to impart its full energy or to transfer its full energy to the electrons. You will find application of this Compton scattering in case of PET scans, that is positron emission tomography scans, means in case of medical diagnostics. Okay, and again for Compton cameras you would find application of this Compton scattering. Next and last comes Rayleigh scattering. Rayleigh scattering, this is not the collision between photon particles and electrons. Okay, this collision is also elastic, same as Thomson scattering. But here the particles or the matter is not electron. It is the molecules of the air. I am talking about right now about Rayleigh scattering, okay? Photon particles and the molecules of the air or atmosphere, not air, atmosphere, okay? So in this case here, the size of the molecules are very small as compared to the wavelengths of the photon particles. Here in this case, in the case of Rayleigh scattering, and the intensity of the scattered photon is inversely proportional to the fourth power of the wavelength of the scattered photons. You would find application of this Rayleigh scattering in case of atmospheric sciences. And by analyzing the results, we can easily say why the color of the sky is blue and why the color of the sunset is red. Okay. Anyway, so this was all about the topic. Topic was interaction between photon and matter. So, or light and matter, and light means photon particles, you know this thing, and matter is here. In the first two cases, the matter was electrons. Okay. And in case of Compton scattering, the electrons are not free electrons. Okay. They are not free electrons. But in case of Thomson scattering, the electrons are free electrons. And in case of Rayleigh scattering, electrons are not there. Instead of electrons, molecules of the atmosphere are there. But here, one condition is there that the size of the molecules must be less than the size of the incident photon particles. Wavelengths of the photon particles. Sorry, okay. Comparison is made between the size of the molecules and the length of the wavelength. Length of the wave or wavelength, anything. Anyway, both are same. Anyway, so this was all about the discussion. Okay, and discussion was what? Just the differences among all these three types of scattering. Okay, and for all the scattering, different application areas are there. I have not mentioned all the application areas. Okay, I have given you just one example for each. Anyway, so this is the end of this video. Thank you for watching this video.